Good morning, ladies and gentlemen. I'm Tony Wong from Tony Robotics, and this is my colleague Jeff Gao, our young senior engineer. I'm glad to present our work on ROSCon again, because we was here last year and we spent 5 minutes to introduce our initial version of RoboWare. I'm glad today we come here again to give a little bit longer presentation to present our new development of RoboWare. There are 3 parts of our presentation. The first part is talking about the pen sports of robot research and development, and the second part will be the introduction of RoboWare and its value. And the third part we'll talk about our future work. So about the pen sports of robot research and development, I don't know the answer from the guys from you, but from us, I think we have 2 pen sports currently. The first thing is we can ask us, are there any tools helping us make an architecture for a robot? Actually, for me, I don't have such kind of tools. Currently, I just use Dia or like the Visual to plot an architectures and use a sheet to describe all the links between different hardwares. So we don't have such kind of a tool to help us to design a robot. The second thing is, are there any tools helping us develop ROS-based projects? Although there are some IDEs listed in ROS Wiki, but actually when we use it, we feel we are quite disappointed with them. So we are trying to do something, new on that. So this is information get from our users. I think that's quite good conclusion. He said in the age of internet, we use like Java, C#, as PHP to develop the website, and they use Eclipse and VS Studio, something like that. And if we go to the age of mobile internet, they use Java, Objective-C, and the tools can be Android Studio or Xcode. But if we look at the age of robots, we are using ROS, and because we come here for the ROSCon, because we are all using the ROS, but we just ask us, which one is the tool for our development? So my answer is none. So that's the reason why we are doing RoboWare. So the third pain point, I think, is we don't have a tool to help us to develop a graphic UI to support our robots. And for the fourth pain point, pen sports is we don't have like a very professional or specific website or any like shops to find our hardware components. So the question is, what can help us develop robots? So that's the reason why we develop RoboWare to help us. For the RoboWare, we split our design into different stages. We call that design, and we develop the software and then the graphic UI. So the first 2 parts are develop the body of the robot, and the third party is for the the graphic UI. So we designed 3 tools. The first 2 called Designer. The second is the Studio, and the third one is the Viewer. So I would like to introduce these different 3 parts. The first is the Designer. The Designer is
okay. In this case, we use Designer to create an empty workspace. And yes, this. In the left, there is a list of some categorized components like embedded cars, rangefinders, desk cameras, motor drivers, and so on. We just drag and drop an Android XU4 card, a Hokuyu UTS laser scanner, a RealSense desk camera, and a customized motor driver, and connect them according to the types of their ports. We can see their descriptions and properties in the right. Finally, we export their packages to a ROS workspace automatically for further development and debugging.
Yeah, we want to use such tools to help us to design the architecture of a robot. So we would like to make sure every part can be connected together correctly, and also these all parts will be with the specific brand and models. So all the software can be downloaded automatically to support these hardware devices. So we are adding some common hardware components, and probably we will open that to everyone here or to the community, so everyone can contribute their hardware to our platform. That will be a big contribution on that. The second part is the studio. Studio is a tool which can help us to create and manage a ROS workspace, create and edit ROS codes, and it can help us to do like debugging both locally and remotely. We also use Studio to do the deployment because we normally control the robots on the embedded system, that's not on our PC. So we can code our codes on the PCs and remotely send the codes to the robot. Then we can run it on the robot, and we can monitor all the parameters on the embedded system. Also, in the Studio, you can manage your package. You can install the packages. You can delete the packages. You can see all the package information, just like make your ROS wiki on your local computer. It's quite easy for you to learn this information. In the future, we will go forward to classify all the packages from the wiki, then help people to find the correct packages to use.
Okay. Here is a comparison between RoboWare and traditional development. In the left, I use Vim and its plugins like You Complete Me, NerdTree, EasyMotion to make a simple Hello ROS project to print a string to the screen. In the right, I use RoboWare to do the same thing. Create an empty workspace, add a package and a ROS node, type some codes, then build it and run the node. With RoboWare, we do all these operations in a graphical way, and some steps like editing CMYK lists can be done automatically. We calculated that it takes only half the time by using RoboWare Studio. Here is another example for remote development from a Chinese robotics company called EAI. They use RoboWare Studio to deploy a ROS workspace from a local computer to their robot. Before that, they usually needed to prepare a screen, a keyboard, and a mouse for their robot to do the development. But now, like with RoboWare, all things are easy. First, they do some configurations on the local PC, then they can do the source coding, remote debugging, and so on the local PC remotely.
Okay, the third part is called Viewer. We use Viewer to do the GUI design and development. Viewer is kind of visual interface editing tool, and here we are quite different with others, because normally we use like a Qt to do the GUI for our robots, but we choose another direction. We use the web technology. We use JavaScript as our coding language because there are lots of resources like the components or some objects which can be done by JavaScript. So we use that to do viewer, which can help us to develop the CMS and UI. So it is definitely cross-platform. It can be used for Windows, Linux, Mac, iOS, and Android. If you can use like a browser, then it'll be okay to run on your system.
In this case, we use RoboWare Viewer to build a UI application to view the map velocities of a ROS robot and control it. First, we drag the components on the canvas, configure the parameters like master IP address, topic names, and types. And then export it as an application for Mac OS. Here we type the name, version, author, and description of the app. Choose the destination and export it. And then we launch the application and click to control the robot. Just like here. And then we can see the map and the real-time speed of it.
Yeah, we can see the meters to indicate like the speed, the angle speeds and everything. Currently, we have some basic components on that, and we are on the way to add more. And of course, if you can, contribute to that database, and that will be welcome to the work. The third part is our further works, and we call our further works RoboX, because we are doing like RoboWare, which is a set of tools to support us to develop robots. And RoboStore, which is a store, can help us to find like proper hardwares and softwares to develop your robots. And also in the future, we will do like education and training. We call that project Robo School. That's our plan in the future. And just briefly introduce the RoboStore. We just put the RoboStore on the website recently, and we want to put, all the hardware and software which can support ROS development to the RoboStore. It is easy for users like to find the proper hardwares and the softwares to develop their robots. So you are all welcome to put your own components on our RoboStore, and we will sell them like to Asia, Europe, and North America. I mean globally. And also there is an issue. It's quite, it's a hot topic recently because we got lots of feedbacks from GitHub. We are, people keep asking us whether we make that project open source or not. Currently, we haven't made it open source, but we promise we will make it open source because more people can get involved and we can get more contribution on that. But so far, it is not ready to open source. We need to do lots of documents, and we need to fix the basic framework and tidy up everything. So we will make it open source soon, and we will let you know on our website when it will be open source. Okay, our aim, like Microsoft make DOS to be a Windows, and like Linux can be Ubuntu with desktop. So Tony Robotics want to make ROS to be like a RoboWare, a complete platform, graphical platform to support robots development. And we have a good wish, contribute to the community and contribute to the robot industry. Thank you very much. Thank you.
Okay. Thank you, gentlemen, for a very interesting talk. Do we have some questions from the audience? Here they come. Okay.
Hi.
Go ahead.
Hi. I've always had trouble with the other IDEs that I've tried to use with ROS, so this looks like a really cool project. Is this IDE built from scratch, or is it based on some other IDE?
It's based. The studio is based on VS Code, which is using JavaScript as well. So our main technical direction is based on JS. For the designer, yes, it is based on VS Code as well. But the kernel is from ourselves. The viewer is completely different with designer and studio, so that's not from any other IDE, so that's all from us.
Okay. So like VS Code is its own, I'm not aware of VS Code. That's a different IDE that already has all the breakpoints and debugging and auto-completion currently implemented and stuff?
Yes, we use VS Code as the core, and we use some plugin, existing plugin, but we do make our own plugins as well to develop the the RoboWare.
Okay, thank you.
Okay, thank you.
Thank you for a very important and needed project. I have a question regarding the quality of the IDE. So why people using Vim or any other Emacs IDE? Because they are tested throughout the time. People can use them very reliably. And my question, what kind of quality assurance are you using in your IDE? Is it automatic? Do you manual test it, or you just wait for users to give you feedback on broader community? Thank you.
Okay, that's a good question. Because from statistics, robot industry is going better and better, and we need more and more personnel. So there are two ways to help people to develop robots. A, you get enough education and training to help people to improve their quality. The second thing is to make some tools to help them to do that things. So, if you are very good in ROS, or you think you have enough quality to do that things, probably you are not the user of RoboWare. But if you are a freshman, then you want to just do a work like research development work, then probably you can use the RoboWare to help you to improve the efficiency and shorten the research and development period. Is that the answer you want?
Yes.
Okay. Thank you.
Hi. It looked like from viewer that you needed a direct connection to the robot and the network, I assume. Do you have any plans for maybe over the internet connecting to a robot? So you don't need to have a specific IP address and port, but somehow you connect, not on the same local network?
We can do that because in our company we have a platform called Data Express, which is based on MQTT protocol. So we have a node on ROS which supports MQTT prototype. Then we can transfer the data from local network to even wherever you want. So we do that, and okay. We also use some we call that the transfer nodes, like transfer the data from C++, the nodes, to JavaScript, which is partially from Rethink. We would like to thank Rethink. They are doing lots of things on JS-based ROS work, so something like that.
Great, thanks.
Okay,
Great.
Thank you.
Okay, let's give our speakers one more round of applause. Thank you very much.